2002, of course, the EU came into force, which provided regulations and recommendations across a number of countries. The OIE, of course, doesn't provide regulations, it just provides recommendations. But with the OIE, I think that's the first example of when there were multi-country regulations. So all countries in the world do some sort of surveillance. We should be able to describe those diseases present in our population, in our animal populations, and their importance, prove freedom of diseases for trade, and detect. We need to do early detection of new disease introductions, changes in the importance of endemic diseases, and of course, incursions of transboundary diseases. And that's important for international disease reporting and trade, but also more and more we manage diseases in our national populations using information that's produced by surveillance. So there are many surveillance stakeholders: the farmers, the public, consumers, livestock traders, all farm support industries, veterinarians, government organizations, NGOs, and of course the international animal health and public health organizations. So surveillance is not just about veterinary services and farmers, it includes a lot of other surveillance stakeholders. And here is my first question. I think who conducts surveillance most commonly is government agencies and organizations. But everybody else in that list does as well. So there are, we do surveillance as an academic research institute in our institute. I developed surveillance systems for swine practitioners in Canada and for national swine associations in Canada. And more producers are, and producers associations are doing their own surveillance system. So one of the things that we work on as surveillance for producers is surveillance for changes in disease status in integrated swine production systems. So these would be systems with 20 or 30 different barns. So the population of swine in those systems themselves is quite large. Okay, so who conducts surveillance? Pretty much all of these organizations, but it's mostly conducted by veterinary services. So in veterinary public health, so surveillance is an important part of veterinary public health. And of course, it's conducted mostly by veterinary service organizations. It's for the public good, and it falls under different legislation and regulations. So of course, there's international recommendations. There's often national acts with regulations. And then at various levels beneath that, there can be legislation and acts as well as regulations. One thing that's important in animal health surveillance is to always remember, and I think everybody probably here knows that, is that resources are always limited. We have to justify all of our expenditures, and efficiency therefore becomes essential. What is a definition of surveillance? I like this slide because it's about the word surveillance. And if you look in the dictionary, it means close watch kept over someone or something as by a detective. But this part about close watch kept over someone or something is what we do in surveillance. So it originally came from was first used in the French Revolution, when it was used in a sort of human intelligence way, where they kept surveillance on different people who might be of interest in the French Revolution. So it comes from French origins, and the word veiller from Latin vigilare, from vigil or watchful. So the definition from surveillance usually has two parts. There's many different definitions available that have been published out there. There's actually a paper on different definitions for animal health and public health surveillance. The risks definition is typical of these definitions. They usually have two parts. One is about data collection, so continuous, repeated measurement, collection, collation, analysis, and interpretation and timely dissemination of animal health and welfare data and information from defined populations. So this is a very precise definition. So that's one part. The second part is that the information is used usually to do something. So to contribute to the planning, implementation, and evaluation of risk mitigation actions. So one is producing information, and two is using that information for some kind of decision making. So we could think of surveillance schematically as, on the left, data collection and observation. So a farmer goes out to milk his cows one morning, and a bunch of them are lame, they're drooling, they're not eating, and they're not milking. So he phones his veterinarian. The veterinarian comes out and has a look and sees lesions along the coronary bands and this sort of lesion in the mouth of the cow, and phones his state veterinarian, his regulatory veterinarian that he's required to report to. They come out, take some samples, and confirm that it's a case of FMD. And then the decision is usually to do something right away because it's quite serious. So of course the farm will be quarantined. There's often an outbreak investigation. There will be trace forwards, trace backwards, and quarantining those as well. So that would be sort of the classical way I would think about surveillance. It's observation or data collection, information production, and then decision and action. The difference between surveillance and monitoring is in the second part. The first part is exactly the same. The collection of data, observation, that's the same. But there is no second part. There is no action associated with monitoring. We just use monitoring to see what's happening in the population, and we have no predefined risk mitigation plan or response plan. That doesn't mean we wouldn't respond or make changes. If we were monitoring something and all of a sudden it went through the roof, then we would probably be obligated as a veterinary service to make some sort of response to it. So an example of monitoring is low-path reporting of low-path avian influenza in poultry and wild birds in member states of the EU. So we monitor the occurrences of low-path AI, but we don't do a lot about them. So we collect and store that data over time to see what's normal. You can't tell whether something is increasing or decreasing unless you have an idea of what's normal. So that's monitoring. So my second question for you, so there's a number of different activities here, and the idea is to tell me which are surveillance and the other ones will be monitoring. Okay, so meat inspection aimed at identifying and removing livers containing liver flukes from the carcass. Monthly reports of endemic disease diagnosis from a veterinary diagnostic laboratory, weekly testing of mosquito poles in a city to detect the presence of dengue fever virus, testing of wild birds for the presence of West Nile. So we want to know which are surveillance. So testing of dead wild boars to detect and respond to a potential African swine fever incursion. So remember, surveillance has a response associated with it, and monitoring does not. 19 out of 22 selected testing of dead boars to detect and respond to a potential African swine fever incursion. Yes, that would be, I would call that surveillance, and I would also call the first one surveillance. Media inspection aimed at identifying and removing livers containing liver flukes from the carcass. The other ones I didn't give a response to. So they are all part of surveillance systems, but reports of endemic disease diagnosis from a diagnostic laboratory doesn't have a response associated with it. Testing wild birds for the presence of West Nile virus often doesn't have a response to it. The dengue one, I didn't put a response to it, but I could see why you'd pick that one, because if the risk of dengue fever went up, you might start spraying in the city for mosquito control, or telling people to wear long sleeve shirts and wear mosquito repellent. So that one might be a little bit one way or the other. Please don't get hung up on trying to figure out whether something is surveillance or monitoring, because in the end, it doesn't really matter. But it's important for you to know the arguments and know this discussion. You can find papers written and published in our field about the difference between surveillance and monitoring. Okay, any other questions before we move on? Okay, I will then start talking about the purpose of surveillance. And here we will talk about the theory of surveillance, policy purpose and surveillance purposes, surveillance and disease control, and how they're related together. And then we'll talk about surveillance purposes. And the four main ones are early detection, freedom from disease, measuring disease, and case finding. So we'll start with the theory of surveillance. So from a big picture point of view, surveillance, we use surveillance to reduce the burden of disease in public health, animal health, and for international trade. So these things, I don't think I have to talk about very much. You all will be aware of them. And if we think of this model and we consider what is needed to initiate surveillance, our model for surveillance is we have data collection and observation that produces information, and then from that we make decisions about actions, disease control, policy development, etc. So what is needed to initiate new surveillance? Well, it's from a philosophical point of view, it is when there is dissatisfaction with the current state and we want to change it, we want to make an improvement. And the thing that we want to improve is the information that we have available. So the source of the dissatisfaction is we don't have some information. We need that information to make decisions about animal health. So we build a new surveillance system or we change an existing one. So the goal, the motivation is to eliminate this need, to fill the need for information. So surveillance, the central purpose of surveillance really is producing information. We talk about two different purposes for surveillance, a policy purpose and a surveillance purpose. The surveillance purpose defines the policy purpose, and it defines what information should be produced and how we're going to use that information, okay? And the surveillance purpose then is the type of information that's produced by the surveillance system, okay? So the policy purpose is when we talk about what's the purpose of this surveillance system. What's it going to do in terms of the big picture? The surveillance purpose is if we're going to design this surveillance system, what information will that surveillance system produce? So we have to always think that surveillance and disease control are intimately linked. So we use surveillance to create information from the population. That information is used for decision making, again, about disease control, policy, measures, programs, responses, and the implementation of that is to reduce the burden of disease. Okay, so that's a linear process. It can also be described as a circular process where we monitor the results of the information of the implementation with surveillance. But this gives you the idea that surveillance and disease control are intimately linked. Barbara Hassler published a paper in 2011 that described this really, really, really well. And I suggest anybody that works in surveillance should have a good look at it. So she presented this model, and that's presented in this graph on the top. The y-axis is the prevalence or incidence of disease, and the x-axis is time. And she divided diseases into 4 types and into 4 different phases: the sustainment phase, the investigation phase, and the implementation phase. And those phases were determined by the situation with the disease in your population. Okay, so we'll talk first about the sustainment phase. And in this phase, the disease may be like epidemic curve A, it might be increasing. There might be short outbreaks that are successfully managed, like epidemic curve B, or it may be absent, like C, or we may not have any information about the disease at this time. So the information that's produced in these cases by surveillance is early detection in the case of C, when the disease is not present, prevalence estimation or incidence estimation for the cases of A, where the disease is going up, B, when we're trying to control a small outbreak, and D, when we have no information at all. And proving disease freedom is for C, when we don't have the disease present in the population. So is everybody okay with that? Any questions? Okay, the next phase is the investigative phase. And here the disease has a significant burden in the population. And we're trying to make a decision about whether we should respond, whether we should intervene, whether we should do something about it, and what sort of intervention would be needed. So the surveillance information is just that. What information is needed to decide whether to intervene and what should be the nature of the intervention. So this provides a little bit more information about where the disease is, how much is there, what parts of the population has it. We make decisions about what sort of implementation, what sort of mitigation we could do, or what sort of control we could do in order to affect the disease. The last phase is the implementation phase. So now we're implementing a control program, and we expect that the incidence of cases will go down as the program is implemented and has an effect on the population. And the surveillance information here is mostly about case detection. So we need to find cases in order to eliminate the disease. And we need to estimate disease prevalence and incidence from time to time as we go through this control program to estimate whether it's working or not. And finally, to stop the disease control or eradication program, we need to prove freedom from disease. So I'll give you the example of the BVD control program in Switzerland. The policy purpose was to eradicate BVD. And the surveillance purpose was to estimate the amount of BVD there was in the population and find persistently infected animals. So the strategy was to eliminate PI animals from the herd. So in the sustainment phase before 2008, there were various surveillance initiatives and surveys to estimate the amount of disease in the population. 2008, they did the investigative phase and they did a census. They did a census of the national herd for antibodies and antigens, and they found 0.8% of the animals and 20% of the farms were positive. So that's part of the investigative phase, but at the same time, they removed all the PI animals in the herd from that national census. Then from 2008 to 2012, during their control program, they tested all newborn calves and removed the persistently infected animals. So the surveillance purpose there was to find PI calves. They decreased the incidence during that time, not the incidence, the prevalence, or the number of cases of PIs from 1.4% to 0.2%. And then in the same sustainment phase, since then, they've done bulk milk sampling of dairy herds and bud testing of beef herds. 2015, they had about 111 herds, 111 farms with newly infected PI animals were reported, and it stayed roughly the same. It's gone up and it's gone down, and there's been a variation over time. but it stayed pretty much in that ballpark. So during the sustainment phase, again, the purpose of surveillance was to find infected farms and to estimate whether the control program was working or not, whether the disease was increasing or decreasing, and it's actually turned out to be relatively stable. Okay, any questions about that? So we'll move on now to the type of information produced by surveillance. And this is specifically about infectious diseases, and there's 4 types of information. If the disease is absent, not present in the population, then we do early detection, or we demonstrate freedom from the disease. If the disease is present, we describe the disease, the amount, the incidence, the level, the distribution, the impact. And if we're in a control program, we also can find cases. So those are really the 4 pieces of information that surveillance mainly provides. There's other information that surveillance provides, but in animal health, these are the 4 main things. So we'll talk about each one, and we'll start with early detection. We use early detection for hazards that are new, so previously unknown. So emerging diseases that we didn't know exist in the past. Schmallenberg is an example of that. Emerging diseases that are changing in importance or region. So the emergence of blue tongue BTV8 in Europe was one of those, and incursions of foreign animal diseases. So if African swine fever is an example, FMD would be an example if it occurred in Europe. The importance is very high. We need an early response to stop the pathogen spread in order to reduce the burden of disease. And if we can control the disease as early as we possibly can, it reduces not only the losses, but the costs for control. And it allows us to return to being free from disease. And if we can eliminate it quickly, it will give our trading partners confidence when we make statements about disease freedom, and confidence that the animals that we trade with them are not going to be infected with those diseases. The goal is to detect cases as early as possible, and that early, of course, depends on the spread of the disease. Something like tuberculosis spreads slowly, something like foot and mouth disease spreads quickly. Surveillance must be highly sensitive, so it must be able to detect cases at a low prevalence, and here we talk about the design prevalence. So we would say with foot and mouth disease, we might want to detect a design prevalence of less than 0.1%. So surveillance has to have a broad coverage of the population, and it has to be continuous. You have to be continually looking for disease. If you do a survey once and then a year later do another survey, that's not really going to provide you with early detection of the incursion of a disease. The surveillance components, that is the types of surveillance that we use, are notifiable and reportable disease programs, and every country in the world has them. Monitoring laboratory tests, slaughter plant surveillance, and syndromic surveillance is becoming more important for this, although it's still only being accepted slowly in most parts of the world. So here we would look at veterinary practice, slaughter plants, farm production data, antibiotic sales, laboratory submissions. I'll talk a little bit about syndromic surveillance later, but this is one of those things where I could have talked about syndromic surveillance first, and then these second, but I think it maybe works a little bit better this way. So the information produced by early detection is the presence of a disease that is important that wasn't in the population before. Freedom from disease, demonstrating freedom from disease, the information that's provided is evidence that the disease is not present in the population. So this can only be done for known hazards, right? They are usually exotic. Well, they're always exotic, so they're not in your country. We've recently completed eradication programs, And more we look at different compartments within countries. So you can demonstrate freedom from disease for one region within your country if the disease is still present in other regions. And of course, this is important for trade, for population health protection, and we need to do this when we want to decide when we're going to end a control program. The goal, of course, is to provide credible, that is believable, which means that our trading partners will believe our evidence, credible evidence of disease or case absence. So the surveillance must be sensitive enough to detect cases if they are present, with a specific design prevalence, and of course it depends. The design prevalence will depend on how quick the disease spreads. So here we don't need to do continuous surveillance. We can do intermittent surveillance and update the evidence as we generate new evidence. It has to be valid, so sampling is extremely important for demonstrating freedom from disease. And you have to demonstrate that your sample is a valid representative sample of the population. Surveillance components, active are representative population samples, and for passive you can use all passive components. So veterinary practice surveillance, reportable disease surveillance, but it is often difficult. They provide credibility, but you often can't provide numbers. You can't use them as quantitative assessments because it's often difficult to estimate the population level sensitivity of passive surveillance. The third information is the amount of disease in the population. So this is for endemic diseases where the disease is present over time. We use this to prioritize hazards by their importance, to support risk analysis, and to characterize hazards. So which subpopulation, which part of the country is in it, what time, what season of the year do we find it? Are there changes occurring? Is it now appearing in certain production types that it didn't appear in the past? The goals are to provide accurate estimates of the amount, prevalence, and incidence and distribution of the hazard in the population. They should be precise estimates, that is lacking random error, and unbiased estimates, which means lacking systematic error. They can be measured ad hoc, periodic, and they don't need to be continuous, just whenever you need them. So the main surveillance component is rapid representative sampling of the population. You have to be very careful using passive surveillance for measuring the level of disease, because all passive samples are biased, and it's difficult to use them to estimate the true amount of disease in your population. So we don't often do that. So the last thing is case finding. This is for hazards that have been recently introduced or emerged in the population, or hazards that we're trying to control or eradicate. And so the importance is initially to stop disease spread in acute outbreaks and to mop up the last case in eradication programs. And the goal is to find all cases, whether the case is a farm or an animal in a geographic region of interest. Surveillance has to be really sensitive, and it has to have broad, continuous coverage and comprehensive coverage. And this is probably one of the most expensive forms of surveillance there are, because finding cases when the prevalence is really low means that even if you have highly sensitive and specific surveillance, you have to test a lot of animals. So we can use active components where we do random representative samples. We can do risk-based sampling, which we'll talk about a little bit later, where we focus on areas or subpopulations where we're most likely to find the disease. And we can also use passive systems. So farmer reporting, veterinary reporting, laboratory reporting. and also slaughter plants, auction market surveys, etc. So here the information is where the cases are. Okay, so that was a big block of information. So we talked, and I'm sorry it was very didactic, me talking and you doing a lot of listening, but we covered the theory of surveillance, the policy purpose, surveillance purpose, the relationship between surveillance and disease control, and the surveillance purposes: early detection, freedom from disease, measuring disease, and case finding. So now we're going to talk about, I'll make this big, about the basic activities of surveillance. And these include hazard selection. So I'll just talk about that briefly because we talked about it yesterday. Case definition a little bit, case finding and case counting, which are the two most important, are the main activities that occupy our time in surveillance. Then surveillance results, communication, and response. So hazard selection. So there's various definitions for hazards. Hazards have the potential to cause adverse health effects, and they can be biological, chemical, or physical agents. And these are what we focus on in surveillance, and mainly the reason why we do surveillance. They can be defined internationally. So we do surveillance for specific hazards because of our obligations for trade, for the WHO, for food safety, for the EU, as well as obligations within our own countries and within our own regions. So sometimes they're mandated, but sometimes we have a number of different diseases that we have to think about managing, and then we can use risk-based approaches to prioritize hazards. And we'll talk about that this afternoon. So the target population is the population under surveillance, and it's the population about which we will make generalizations about. So it can be defined in a number of different ways. It can be the whole population for the country. We can do it for specific species, for specific production sectors, specific geographic regions, and the samples that we take, the data that we collect, and the observations that we make are collected from the target population. Case definitions we talked about yesterday. So they are either an animal or a farm plus a hazard equals a case, and a case is any animal or farm that meets the case definition, and the definition is all criteria needed to classify an animal or farm as a case. Case definitions are very important because if they're done improperly, they can affect the sensitivity and specificity of your surveillance. They change from disease to disease, and they change over time through the stages of a diagnostic process, or especially with emerging diseases, it will change as we learn more and more and more about a disease. Defining the hazard or making the decision whether an animal or a farm has the hazard or not is done with any information that we have available to us, and it varies again with how much diagnostics are done on the animal or farm. So we can use clinical signs or syndromes, and early in the course of diseases, we often just use syndromes. But we can also use pathology, laboratory tests for toxins, laboratory tests for the host responses, such as serology, risk factors, and indirect indicators, such as drug sales, performance information, mortalities, abattoir submissions, condemnations and partial condemnations at the slaughterhouse. I put this slide in of Jordan's because I didn't really talk about the epidemiological link. So for the EU, a suspect case has three characteristics: some sort of clinical signs, postmortem signs, a diagnostic test and a diagnostic method, and an epidemiological link with a confirmed case. So that's important to make a case definition for a suspect case. Some examples are bovine, this one developed for bovine neonatal pancytopenia. So here it is a calf that's 28 days of age or younger with unexplained hemorrhages at necropsy with trilineage hypoplasia of bone marrow. So trilineage hypoplasia of bone marrow is depletion of erythroid, myeloid, and megakaryocytes from the bone marrow with resulting in less than 25% cellularity. And this, of course, has to be done on postmortem with histopathology. Another example is the one that was developed by EFSA for Schmallenberg virus, and it was stillbirths, premature births, mummified fetuses, and dysfunctional fetuses with two or more of any of the following: arthrogryposis, hydrancephaly, that's spelled right, and any of these others. So two of those in a stillbirth, premature birth, or mummified fetus. Case finding and case counting, I have one slide on this, and this is what we spend most of our time doing in surveillance. So finding cases, we've talked about sampling yesterday, notification programs, all of the things that we do mostly to find cases is probably one of the most important, probably the most important activity in surveillance. Then we have to count them, both cases and non-cases, because we need denominators, and we look for increases or decreases in the number of cases. So an increase in cases is an outbreak or an epidemic, and we can't do this unless we know the expected number of cases. So monitoring to establish normal values is very important for surveillance, because it's what we use to tell whether something is changing in our population or not. Surveillance results, since we do counting of cases, the two main results are incidence and prevalence. Incidence when we find new cases, and prevalence when we look at the amount or the proportion of cases in the population. And we often group or describe these cases with a number of different characteristics, such as sex, age, geographic region, productive type, season, and other things depending on the disease. Communication and response is very important, and for important diseases that we know about, especially those that are transboundary diseases, we often have predefined communication channels. We have to notify only specific persons, and only when we have a confirmed or different stages in the diagnostic process. This is often really tightly controlled, because premature communication can have quite severe consequences. One example is when BSE hit North America. It hit Canada first, and then of course we sent a case to the US and caused them a whole bunch of problems. When they started doing surveillance, they used one of the new, at that time, ELISAs, and they were going to be very transparent with their surveillance. So the first positive they got on ELISA, they reported internationally, and the price of cows, calves, and slaughter carcasses in the US promptly went into the cellar, and it really had a huge effect on the market. And 2 days later, they confirmed that it was a false positive. So we all learned after that we would be very careful about how we reported our BSE surveillance results. Responses are also usually predefined, especially when you have to move quickly for something that spreads rapidly. And there can be a huge range of responses depending on the type of pathogen. Often the first one, when you get a suspect case, is to investigate the case to confirm that it's true positive or not. And then things like carcass removal, product recall is done in food safety, but quarantining and things like that are also done immediately. And then an emergency response plan is often activated. And of course, the lessons learned from this whole process results often in new response plans and changes to policy. So that's surveillance for surveillance activities. There's a lot more to this, but this is an introductory course, so we can't really dig deeply into any parts of these. We can only talk about things on sort of the surface of them because of the time limitation.